Questions for Cindy? Cindy, if you're successful, go ahead. If you're successful with generating the carbon molecules that you want to generate, what's the likelihood that it can be done with less energy input than what you're hoping to get out?
You mean for the entire CSER process?
Yeah.
Well, the waste energy system, what I show is a simplified model, but if you start with the feedstock, then we're hoping that the energy that would be generated from that would make it self-sufficient. So we wouldn't actually be using an outside energy source like we are now in the laboratory setting, but that's because we separated one of the reactions. But that's waste energy isn't something new. It's been around since the early 20th century. And so with those systems, they are designed to be self-sufficient, to not use an extra amount of energy like fossil fuels, so then it would defeat the purpose.
Right. So people have looked at this and think that it's realistic.
There are currently 2 waste-to-energy facilities in California. There's one near LA and then one in Northern California. These aren't the only ones in California, but these ones specifically handle municipal solid waste and turn it into electricity. So they handle the one in Northern California handles 800 tons per day, and I think the one in Los Angeles handles a lot more.
And they're also going through using carbon monoxide and
they're all different techniques. CSER is using steam hydrogasification. The one in Commerce, I think, is more combustion. But there's several different types, and it all depends on temperature, pressure, it depends on water, if you're going to dry it out. UCR actually sends 12% of its waste to a waste-to-energy facility. So it's something that's becoming more common because we're running out of energy.
So in terms of overall life cycle costs, for example, if you're trying to convert municipal solid waste into carbon monoxide, and the gasification process and so on, do you have a sense of what the emissions for that are like?
Well, it's actually gasification is partial combustion, so it's not even creating greenhouse gases. But through the entire system, of course, there's going to be some gases that are not ideal and we don't really want being released into the environment. But
so you don't have NOx or SO2 or something like that emitted through this?
No. And then, but for the entire process, at the end, there may be some gases released, for other waste energy systems, and there's a plethora of different air pollution control devices, like baghouses or activated carbons, scrubbers, like acid scrubbers. So those techniques are being used. The facility I mentioned in Commerce combines multiple air pollution control technologies to ensure that it meets the air quality standards, so that it's not emitting toxins around the city.
So one more question. So when you talk about the different fractions that came out of the conventional Fischer-Tropsch, would that go into the normal refining process so that and distillation so that the different fractions are distilled?
Are you talking about these products?
Yeah, or the one below. For example, you want to get rid of all the C13 through the diesel stuff.
Well, I'm sorry, I don't quite understand.
So if you had to go with just this, would you then process it through a distillation process to get rid of, to separate out the?
Well, so the fuel grade standards. There is high fuel grade standards, so there may need to be some diffusion analysis for this experiment. But as far as what's currently being produced from Fischer-Tropsch, it's obviously more efficient to be running it with the zeolite catalyst because you can't do anything with those hydrocarbons. It's produced as wax, and that needs to go through several hydrocracking and isomerization. Versus with the zeolite, it kind of eliminates those refinery processes. Yeah. Okay.
Was this new catalyst developed here at UCR?
Yes. It was synthesized over at CSER.
It was?
Yes.
Do you know what the metal core is?
Cobalt.
Cobalt.
Cobalt, yeah.
And it's coated with a zeolite.
And it's coated with the ZSM5. Yeah, so that's why one of the future modifications we're looking at is maybe choosing a different transition metal than cobalt something that falls lower on the periodic table. So that would be less corrosive to oxidation, or more resistant to corrosiveness and oxidation.
I have a question.
Yeah.
It seems like there's a lot of factors and a lot of different levels for each factor. Are you using any statistical modeling to predict which is going to give the maximized output of it?
Yeah, so before there was a life cycle analysis done of gasoline, and so looking at the entire, from when it's in the ground to when it's emitted, every single step there was done a kind of an environmental report to figure out how many emissions is being from each of those steps.
Mm-hmm.
So yeah, with this project, we do have some emissions that are released that are also being ran through gas chromatography so that we know how toxic they are. But comparatively to oil rigs,
yeah.
There's no land degradation for these type of things. We're not adding toxins into water or soil or vegetation. So economically and environmentally, the cost associated with those aspects of the well-to-wheel versus our experiment is has been determined to be more efficient. I was super excited when we got our results. I was like, yes, it's working.
Additional questions for Cindy? Okay. Thanks once again to all the speakers.